All right, had some kind of glitch on the on the recording. Sorry about that. So we'll jump in with part two and we'll continue on question number 7. So observe it's possible to build a triangle with toothpicks that has sides 3, 4, and 5. Find two other triples of toothpicks that can be used as sides of a triangle and two others that cannot be used to create sides of a triangle. Again, if you think about it, this really does tie right back into that triangle inequality. So I'll let you use that knowledge to continue this problem. But there's infinitely many that can be and infinitely many that cannot be. So that's kind of a fun fact. All right, let's take a look here. So that was question 7, and then 9 through 12 is the last piece. So now we get to connecting math to the classroom. So this one's about a tennis ball can, and if you've ever seen them, they have typically, oh, let's see here. I almost drew the circle tool. I don't want a circle tool. Something like this, right? And then inside, there's usually 3 tennis balls kind of stacked. 1, 2, 3. So if you were counting and measuring from top to bottom, not in inches, but in diameters, how many diameters would it take to get from the bottom to the top? And see if you can connect that back to what we did in class with how many diameters are in a circumference. See if that doesn't connect those two concepts. Next, why 22/7 cannot be used as a value of pi. Well, I mean, you're welcome to it. 22/7 is the estimate we got in class, 3 1/7. But again, that's very, very rough. It's an approximation. Actually, 22/7 is equal to this, which is approximately pi. But just remember, pi is a certain type of number. This number is known as a rational number because it has a decimal form that can turn into a fraction. Can pi actually be turned into a fraction? And think back to what it means to be an irrational number. Let's see here, a wire stretched around the earth. If you cut the wire, increase it by 20 meters, and then restretch it, the tallest person alive could walk under it. Wow. I don't know. So start with what you know. You know you have the earth with a certain radius, and then you're going to basically put a piece of wire that represents that and then stretch it out a little bit and then redo it. So what we need then is we really need to know what is the radius of the earth, because that'll get you the circumference of the earth. And once you have the circumference of the earth, then you need the circumference of the earth plus the wire. And that's just whatever you find for the circumference of the earth plus 20 meters. So make sure when you find the circumference of the earth, go ahead and use Google if you need to. I don't know if you'll need to do that. You can probably do this problem without finding that at all, but you could look it up if that makes you feel more comfortable putting numbers in. Make sure you measure it in meters so you can add 20 meters to it. And then go back and find what's the new radius, right, out to this new edge. And the difference between those, you have to be able to see, can a person walk underneath it? And I'm not sure. Be interesting to see. And let's see here. Student claims circumference of the semicircle is this equal to the sum of the circumferences. Yeah, this is a great question. So a student happens to notice something. And this is a great chance here for GeoGebra. Like if you were doing GeoGebra, you could actually have GeoGebra measure this, measure that, and then measure the long one. And then you could grab A and kind of drag it around and see what happens to those. But a student notices, looks like the two littler ones, if you add those together, it gets you the big one. And she's like, that seems kind of weird. Does that always happen? And so we can kind of take a look. So whatever the circumference is, we know circumference is either pi times the diameter or 2 times pi times the radius, your choice. But what I have down here is I have, let me change color real quick, make it a little bit thicker. So then right here, like this thickness right here, that's like the diameter of circle AC. And then right next to it, I have the diameter of AB. So what I probably want to do is I probably want to say like D1 and D2. Okay. Now you could find radius 1 and radius 2 if you prefer. So you could have, let's see here, over here, you could have like radius 1, and then right next to it, you could have, radius 2. So you could use whichever of these you prefer. I prefer R2D2. Oh, Star Wars joke. Okay, R2D2. That's what I prefer. But I'd probably keep it with diameters. And that's because if you add those two diameters, D1 plus D2, that's actually the diameter, if you add those together, you can think of it as being D3, which is the diameter of the bigger circle. And so again, think of that and then add those together. You don't need to know the lengths. You don't need to know the lengths. Just like in question 12, you actually don't need to know the radius of the Earth at all. So there you go. Remember 20 meters, remember that rule of thumb? A meter is about 3 feet, so that's about 60 feet. If you think about it, is all that's being added in terms of length around the entire Earth, is that enough to get it so someone could walk underneath it? I don't know. That seems a little sketchy, but I do know the answer. Maybe I'm playing that it's sketchy and I actually know the answer, but when I first saw this question, I guarantee you, I said, that's sketchy. There's no way. All right, that takes care of 13.1 multiple math connections questions. If you have other questions for me, please let me know. I can respond with a video or meet you in person or on Zoom. All right, have a great rest of your day. Off you go.